So today I'm going through some of the visualization that I have made with the D3 block builder. This is my main page on block builder, and all of my visualizations and data tables are available here. By clicking on any of these blocks, we can go and see the visualization and the code. For example, this is a representation of the global temperature anomaly since 2001. Data is obtained from NASA's database, and each bar shows the level of temperature anomaly in each year. Here, if we click on open, we can see the whole bar chart here, and clearly the increasing level of temperature change since 2001. Going back through the code, we can see how we define the font size and the colors here in the body part of our code. And then we have the title of the bar chart. We have the value of each bar and the name of the bar here. We have defined as a constant variable. And then we have the margins here, margins of our visualization. Here we show how we define how we want to represent data, the orientation of the plots, and the values that are represented in front of each bar. Another visualization that I have here is a Gini index of 4 countries through the past 3 decades. You can see here that Brazil has not done a good job on the Gini index, and during the past almost 25 years, Gini index has decreased. Argentina did not have a good Gini index overall, and then we have United States that continuously is increasing, and we have Turkey with some fluctuation. And the data is obtained from the website Our World in Data, which has very useful and interesting data in it. The plot itself is forked from Kern's stylizer scatter plot with color legends. And here we have the code that we have the labels of the scatter plot, we have the legends, and then we have the margin, and then the inner margins, and then we have defined the axes. So X label, what does it have? Y label, and what does it have? And the colors and the ticks that are basically, if we go back here, are the horizontal and vertical ticks on the plot. And finally, the type of our marker and the representation of our markers that are circles, and the size of them and how they're colored and things like that. Another presentation here is a representation of population of the world at each time, at each year, living on the certain political regime. As we can see, it's kind of a stacked plot. So Altogether, here in 2010, we have over 7 billion people. And then by going on each political regime, we can see the share of it and how this has changed. For example, before 1940s, almost before World War II finishes, we didn't have much democracy in the world, and then the level of total amount of democracy in the world and people who actually lived under democracy has increased significantly. Interestingly enough, the amount of people who are living under autocracy is has also increased. So the data is also provided by our world in data. I have used two separate codes to generate this code, and the code is basically forked from those codes. This is rather interesting visualization because although it's very similar to previous ones, but it has some different parts. For example, here we have read data using v3.csv, and then we have used this render function to make the stacked plot that we had. Our variables or attributes are defined here and stored in each of these variables, and then the keys are defined here based on the names that are defined before, and then we have here defining our X scale and the format of our variable, which is a time variable, so we need to have defined formatting of our variables. Here we have defining how to stack the data, and then the ticks of our plot are defined here, the axes, x and y axis, and the major and minor ticks are defined here, and that is basically it. Another visualization that I have made is this stream plot of unemployment rate for different category of countries, economical categories of countries, which is G7, Europe, advanced economies, and other advanced economies. And if we go down here, we have a description of each of these labels that is provided by International Monetary Fund, and it's kind of quite interesting that we can see after 2008 the level of unemployment in Europe, G7 and advanced economy has increased, and this is probably due to the financial crisis. And some of the countries actually that are not quite connected to the big industrial world are not that much affected, but are still affected. The stream plot actually is made very similarly to the stack plot that I showed you before, with some small changes. Same way we read our variables, and then we read the data file, store it, and then we use the render function to render the visualization the way we want, and then we have the keys and their names here. We define the axes and then the margins. We have here how to show and put plots together, put the numbers together, and then the scales are defined here. Here we have the energy efficiency data, which is from a paper that is provided here. If we go here, we can see the main paper here. Here, accurate quantitative estimation of energy performance of residential building using statistical machine learning tools. This is actually quite interesting paper with a high number of citations. And here I have made an correlation matrix scatter plot for the variables that we had. And if we go back here, we can see the correlations. Actually, here we have two main features or functions that we are looking for, response functions that we are looking into are important for us, the heat load and cooling load. And then the input variables that are affecting directly or indirectly these two main important response functions that we want to optimize. So we can see, for example, that surface area has very strong effect on both heating and heating and cooling loads in a building. The overall height, roof, we can see all of them have strong effects, and we can also see that there are some relations between even the input parameters and how actually they are related with each other. Here, back to the code, it's also similar to the two previous codes. We have defined our the names of our variables, and then we have read the CSV file here, and then we have the constant names of the keys, parameters, and so forth. And here we have the function for the scatter plot and the part that when you go on your code and when you go on each of these, it tells you. You see, for example, if you go here, it says relative compactness versus roof area, which are these two. So yes, this is the part that we have defined those variables. Finally, the main CSV file is loaded here. I hope you enjoyed this presentation. Thank you for your attention and have a good day.